Good evening, sir. My name is K. Dhananjayalo. I'm Triple E department. Subject name is linear algebraic and calculus. My topic is changing the order of integration. Subject code is 23MAT01. So it is small introduction to our changing the order of integration. In calculus, interchange of order of integration is methodology that transform integrate integral of the functions into other, hopefully simpler integrals by changing the order of in which the integration are performed. Choose u and v functions. Differentiate u dot u dash. Integrating v dx. If u dash are put integral v dx into the given formula, u integral v dx minus integral u dash into integral v dx into dx. Simplify and solve the integration by parts examples. Changing the order of integration. To evaluating a double integral, with integrate first with respect to one variable and consider a other variables as constant, and then integrate with respect to the remaining variable. In the former cases, limit of integration are determined in the given region by draw a strips parallel to y-axis, while the second case by draw a strips parallel to x-axis. Reversing the order of integration. When evaluate the double integral, we can either integrate with respect to y first and x or vice versa. The method reversing the order of integration. Suppose we have situation of finding the double integral of type 2 regions, that is my problem is evaluating integral 0 to 1 integral x root 2 minus x square into x by root x square plus y square into dy by dx. Solution: y is various from x to root 2 minus x square and x is various from 0 to 1. We draw a visible region R by the given coordinates at a equals to 0 comma root 2, b equals to 0 comma minus root 2, c equals c comma c into root 2 comma 0, d equals to minus root 2 comma 0. By changing the order of integration, we draw a strip parallel to x-axis is various from 0 to root 2 y square at y limits. Y is various from 0 to 1. Integral y equals to 0 and 1. Integral x equals to 0 root 2 minus y square into x by root x square plus y square into dx. Y equals to 0 to 1, x equals to 0 to root 2 minus y square into x square plus y square whole power minus 1 by 2 into dy by dx, dy into dx. My 1 by 2 equal 1 by 2 into y equals to 0 to 1 limits x equal to 0 to 2 root 2 minus y square into 2x into x square plus y square into whole power minus 1 by 2 into dx into dy. 1 by 2 equals to integral y equals to 0 to 1, differentiating the values x square plus y square plus into whole power minus 1 by 2 plus 1 by minus 1 by 2 plus 1 limits 0 to root 2 minus y square into dy. Integral y equals to 0 to 1 x square plus y square whole power 1 by 2 limits is 0 to root 2 minus y square into dy. Integral y equals to 0 to 1 2 minus y square plus y square whole power 1 by 2 minus y square into whole power 1 by 2 into dy. Integral y equals to 0 to 1 root 2 minus y into dy root 2 integral y equals to 0 to 1 dy minus integral y equals to 0 to 1 y dy root 2 into y into limits 0 to 1 minus y square by 2 into root 2 limits 0 to 1 root 2 differentiating y equals to 1 minus 1 by 2 or differentiating y square equals to 1. The answer is root 2 minus 1 by 2. Root 2 minus 1 by root 2. The conclusion is, if you have a double integral over a region R with the inner integral integrating with respect to y and the outer integral integrating with respect to x. You can change the order of integration by reversing the order of integration and limits of integration. Thank you.